Hi everyone! Now that we know a bit about early hominin niche construction and artistic expression, let's talk about something a little more utilitarian: tools. We'll start with stone tools and how they helped early researchers conceptualize what's known as deep time. What do I mean by deep time? Well, prior to the 18th century, archaeological and historical research followed the tradition of the Renaissance-era philosopher Petrarch, who believed that understanding the past was the basis of morality and Christianity, and spearheaded the focus on classical civilizations of the Mediterranean, like Greece and Rome. This scope did not challenge the Christian Bible as the authority of the origin of the world and humans, and persisted for the next 400 years. To further add credence to this framework, James Ussher, who was the Archbishop of Armagh among other titles in the mid-1600s, calculated through information gathered in the Bible that the first day of creation was specifically on October 23rd, 4004 BC. That would mean that the Earth is only about 6,000 years old, and that everything we see today was created in its current form. This was widely accepted, and to go against this ideology could be punishable by death. Problems arose, however, with the crude stone tools discovered in England and the continent of Europe, along with the bones of long-extinct mammals in the same context. These stone tools were written off as meteorites produced by lightning, elves, or fairies, hence the name fairy stones. These fairy stones were also found in America during the colonial period and were compared with the European tools, which suggested they derived from the same tradition. This is important because colonists directly observed Native Americans manufacturing stone tools, which were so similar to those in Europe that it began to foster new ideas of the stone's origins. Of note, Jacques Boucher de Perthes, an archaeologist in the mid-1800s, proclaimed that the stones proved the existence of very ancient man, and that prehistory in Europe must have included a stone-based technology, which would mean history was far older than once thought. This idea was further backed in other disciplines, such as geology, by prominent geologists James Hutton and later Charles Lyell. You may recall these names from our first lecture video when we introduced the principle of uniformitarianism. This principle was founded on the recognition that wind and rain caused erosion and formed sand, small rocks, and soil. These particles could then be redeposited, forming the layered pattern of rock we call strata or stratigraphy. However, a few thousand years was simply not enough time for this process to occur. It would require millions of years. Hutton's ideas of geological strata and time depth rely on the assumption that the processes that occurred today are the same ones that have occurred in the past. This is known as uniformitarianism, an idea that is widely accepted in all scientific fields today. Archaeologists utilize the principle of uniformitarianism both on the macro scale, when trying to place finds in deep time, and on the micro scale, when assessing the layers of soil in excavation units on archaeological sites. This convergence of evidence eventually led to the realization that the Earth is in fact 4.6 billion years old rather than merely 6,000. Once a sense of deep time was established, researchers began trying to place stone tool technology chronologically in time. Christian Thompson developed the three-age system of the Stone Age, Bronze Age, and Iron Age in 1836, while John Lubbock divided the Stone Age into the Paleolithic and Neolithic in 1865, based on changes in stone tool technology. By classifying these tools and recording when certain types existed in time, these artifacts became time markers, which are materials or fossils that, depending on where they are in the Earth's stratigraphy, can help us date how old the materials or fossils are, and therefore help us date other items that may be found in the same stratigraphic layer. This is also known as the index fossil concept. In order to understand the technology of ancient humans, archaeologists analyze stone tools and the debris, called debitage, left behind when tools are made. Humans use technology to manipulate their environments. Some anthropologists and archaeologists have emphasized the role of technology as the interface between human societies and environment. At this point, you may be asking yourself how we identify the previously known fairy stones as artifacts over regular rocks. There are a number of telltale signs that indicate human manufacture rather than natural causes. All stone tools start out as, well, rocks. The rock chosen to begin tool manufacture is referred to as a core. The core is struck with another rock called a hammerstone, and the stones that break off from the core to fashion particular points are called flakes. The excess debris that results from creating flakes and shaping a core is the debitage mentioned earlier. Both the core and the flakes can be made into specific tools, and the process of manufacture is commonly known as flint knapping or just knapping. For example, flint flakes are produced by striking a flint nodule with a hammerstone. A single blow at the platform of the core produces a flake. Flake scars on the core indicate where a flake has been removed. Landmarks on the removed flake, such as the bulb of percussion and ripples, offer evidence of a human purposefully striking the flake from a core. The extensive cortex on the exterior surface shows that this is a primary flake, which is one of the first struck from the core. Primary flakes can be further chipped into a shape of the knapper's choosing, whether that be a projectile point, knife, or other tool. Analysts sometimes practice refitting to learn about the knapper's task sequence. This core produced blades, and when reassembled can show where the napper shifted grip on the core to strike other facets. Such work helps us understand the level of skill, handedness, and intent of individual ancient toolmakers. Because lithics are very durable and were used by hominins even before the time of Homo sapiens, they provide a long-term, enduring, and relatively constant marker of human technology. The study of lithics examines both the form of the final tools and the technology used to make them. Stone projectile points that look very different from one another can be used by a hunter to kill the same animal. Form is often considered a matter of cultural preference or identity. People usually have a culturally acquired sense of how a thing should look. Sometimes form is also tied to function. A long edge or thick point may perform differently from a shorter edge or thinner point. Technological analysis of stone tools examines the way in which a knapper produces a tool. The knapping sequence, or operational chain of steps, describes lithic technology and helps archaeologists recognize culturally specific ways of making tools. There have been some big mistakes made by archaeologists who looked at the final forms and assumed that two tools had been made by people who shared a common culture. Closer study of the technologies has demonstrated that two tools can look the same, but be made differently. Technological analysis also forces archaeologists to study debitage, so that the entire range of activities at a site becomes apparent. Once archaeologists have completed a technological and typological study of lithic artifacts, they are ready to use assemblages, or all of the artifacts at a particular site, to understand site economy. How are humans using stone tools to produce, consume, or exchange materials at a site? Were they grinding grain, stripping hides, refitting hunting spears? As the technological interface with the environment, stone artifacts help archaeologists understand the ancient economies that link societies with their environmental circumstances and cultural contexts. It's important to note that flint knapping was the first human technology, and tool-making techniques repeated over hundreds or sometimes thousands of years are evidence of a long-term cultural transmission of information. The tools made by the earliest and oldest hominins, Homo habilis, are referred to as the Oldowan industry. Oldowan tools were ideal for cutting hides and breaking joints. Remember, Homo habilis was the first hominin to rely on tools for their survival, which differentiates them from their evolutionary predecessor, Australopithecus, who sometimes used tools but didn't necessarily need to. Homo erectus's tool industry is referred to as the Acheulean, which includes advanced bifacial hand axes that look like teardrops. Acheulean tools required an increase in cognitive ability, which is reflected through the increase in brain volume from Homo habilis to Homo erectus. Hominin brain size continued to grow, and with that growth came superior intellect and more specialized technology. Neanderthals produced the Mousterian stone tool industry, which involved retouching flakes. This is where one edge of the flake has been trimmed to improve its sharpness, and therefore its utility. In the level-la tool industry, a core is first prepared to make one or more preformed flakes. Level-la points were made by both Neanderthals and anatomically modern Homo sapiens, more than 40,000 years ago. Additionally, modern Homo sapiens use perforated shells and ochre as decoration, which is a mark of social consciousness, and invented blades as well as compound tools, which included the blade, shaft, and haft. You can see now that there are certain continuities in tool industries, which allows us to place them in space and time, know what kind of hominin used them, and understand knowledge transmission and cultural traditions in antiquity. Fast forward to 7,000 years ago, and we see metalworking appearing in the Near East and Europe, showcasing further complexity of thought and reasoning. Some believe interest in metal was probably sparked by the bright colors of the ores. They must have been pretty beautiful, considering the amount of work and manpower involved in extracting, transporting, and smelting metal takes, as it took a large number of people, which also means that social cooperation was a necessity. Check out the videos below to see reconstructions of how past peoples worked with copper, bronze, and iron. Archaeologists focus on stone and metal objects because they survive best in the archaeological record. This means that perishable technologies from the past are seldom found, although there are some exceptions. Otzi the Iceman lived and died between around 3350 and 3100 BCE, and his body and possessions were preserved by a glacier. The preservation of his clothing and tools provides insights into ancient technologies that are usually not found. For example, Otzi's clothes included a hat, cloak, shirt, leggings, and shoes. Their production suggests well-established clothing manufacture, including expert tailoring. His clothes also demonstrate the technology available for curing hides. Your textbook goes into much more detail about the finds associated with Otzi, but what's important to note is that it took complex thought and long-standing cultural tradition to fashion his clothes and supplies. The technology that went into making Otzi's clothes and possessions shows that although he was a solitary hiker, he was tied to his community. As we can see, tool technology has changed throughout time. These artifacts, like all others, are microcosms of the cultures that created them. Every artifact was created with a purpose, to fulfill some cultural role, whether it be a tool for food production, a weapon, or a ritual symbol. Knowing this, archaeologists try to decipher the culture of the people through the items associated with them. Think about it this way. What items are you using right now to watch this lecture video? Maybe a desktop, laptop, tablet, phone, or headphones? What role does that item play in your life? In other words, what cultural need is the item helping you achieve? At this particular moment, I would say it's helping you engage with this lecture video to help you get a good grade in the class, which will help you earn a degree. By earning your degree, your social capital will increase in society, and you may be offered better opportunities than those who do not have a degree, therefore leading to a better quality of life. The things we use are a means to an end and help us connect to and participate in our cultural realities, the same way stone and metal tools aided and abetted past people to thrive in their time. Today, take a look around your living space and consider what items help facilitate your daily life, and try to imagine if a future archaeologist would be able to discern your culture. That's it for today, and I'll see you next time.